FYI, Ted is over in Bath, England right now giving a workshop on applications, tools, and data. And he was invited to speak there. So it's pretty fantastic for our working group. Just that little notice. He'll be back on our next call on June 24th at 1 p.m. Um, some other business to get into before we get into Mike's demo. Thank you for taking notes, by the way. Um, I just wanted to let you guys know that there is going to be a apps contest for the conference. And I was asked yesterday by Mike Conlon and the conference organizers if I would do the judging and present the awards. So what I'd like to do is just kind of make you guys aware of it. The announcement's probably going to go out sometime in the next week or two about the contest. And so I was hoping to be able to pick some people from this group to help me do the judging. So just kind of keep that in mind. I'll probably be sending out an email to Apps and Tools in the next week or so to help. And typically, Mike said that there's usually only 5 or 6 submissions, so it's not like a lot of judging. But we will judge the best app, and the winner of the app contest will get a free registration for the following year's VIVO conference, and they'll also get an award that we'll present during the opening of the conference.
Hey, Chris, this is Lane. That sounds great. When you send out that announcement, would it be okay? Would you be able to CC me on that so I can also use the channels at DuraSpace and make sure that we get the announcement out? And would this be something that we would want the conference, the meeting conference facilitators or the people who are running the infrastructure stuff to send out an announcement as well?
Yeah,
Lane, yes, I'm talking to Rachel about that, and she will send out an announcement about it.
Okay, great. So I'll just need to know, Chris, then the information so I can get it out through DuraSpace channels, okay?
Oh, absolutely. Yeah, I was just as far as I know, the conference organizers are sending it out, so I'll be happy
Perfect.
to run that by you too.
Yeah, very good. Thank you.
I was going to be funny and say, "No, Lane, you can't see it at all. It's a secret." But I know how sensitive you are in your new job. So
Yeah, I'm just like trembling.
It's too bad. That would have been funny.
oh man. So anyway, that's pretty much all the apps and tools business we have, other than the fact that I posted the previous calls video last week, but I forgot to send out an announcement, so my apologies. But the link is in the top of the agenda to the call of the previous apps and tools call video where we had an open discussion with the ontology team, and we got quite a great discussion going about the ISF ontology. So if you're interested in hearing about that and hearing what their thinking is, there was a pretty good discussion around, for example, why FOF and VCARD are used, and which ontology standards choices are made and why. So it's a pretty interesting discussion. Also, I would encourage anyone who has time to drop in on the ontology calls, which I believe are hosted this week. They're every other week, and it's on the same week as this call. So they're Thursdays at 12 p.m. Eastern. And again, that's the ontology group call led by Brian Lowe and Melissa Hendel, and they're at 12 noon Eastern on Thursday. And so this week's call is on June 12th. So without further ado, we have a invited speaker today, and it's Mike Conlon, who all of you know is the PI of the VIVO grant, and he's also an avid application developer and Python programmer who's done some fantastic and amazing work. We'll put a link in here to his GitHub site where he's got lots of work that he's done represented that you can go read about, and you can read his blog. But today he's going to be talking about some data visualizations that he's done using the data-driven documents, libraries, and JavaScript D3.js. So without further ado, I will give you presenter, Mike.
All right.
And it's coming right at you.
Okay, show my screen, press, you have been made the presenter, please close confidential. Okay, all right.
There we go. We can see your screen. Lots of trees with snow.
Yeah, well, it's hot here, so any any visualization is a good, you know. All
Cool
right,
thoughts, right?
all right, very good. So let's see. So some of the people on the call were present at the Vivo hackathon, where I talked a little bit about what I'm trying to do with in creating a Vivo Expert Finder. Today, I'm going to be doing an update on the work that's occurred since the hackathon, but also a little bit of a deeper dive into how some of the work gets done. So a little more instructive about the kind of technologies that we use, D3 for visualization, and Ajax for making queries from JavaScript, and JavaScript itself, Python, JSON, the normal constellation of tools that we're using to create some of these applications. So why an expert finder? Well, for people who've been hanging around the Vivo community for a while, I hope this is pretty obvious, but it's, we kind of start with the idea that collaboration is the future of scholarship. It's just not possible to do complex scholarly endeavors, particularly in the sciences, without some kind of team. And finding team members and experts can be difficult. The University of Florida is really big, so we have about 6,000 faculty. When our data gets pooled with those other data, Dave Eichmann's got the CTSA search thing up and running with more than 100,000 people in it. And if we were thinking about a Vivo search at the world level, there's a lot of people, and so finding expertise can be very difficult. But I do believe that for an expert finder, the cost benefit for developing such a thing is really changing with the tools that I just mentioned. So we've created a lot of data with Vivo. We're creating more every day, and now we have a set of tools that are really capable of exploiting that data in some reasonable way. So it doesn't take 5 man years to create something. You can do it a lot easier than that. So let's get in a little further. I showed this at the hackathon. This is my top level architectural picture. So I try to keep things simple, but I believe you're supposed to be a user. There's supposed to be a compelling device that the user can interact with, typically a tablet, and then a comprehensive and robust data store in the back that is representing data, and you see that the data there in the Vivo store is represented in triples. So you see all the triples there. So that's about the level of detail on the architecture, and we're actually going to execute it that way. We're going to use a browser. We're going to interact with the browser. The browser is going to interact with Vivo, and kind of keep it at that level. So what kind of data are we talking about? Well, for an expert finder, we're talking about papers, because they are evidence of expertise. So we like to count things. We like to have clarity around these things. So we're not just going to ask people what they're interested in. We're going to use the papers they've written as an indicator of what where they have expertise. We use the term paper loosely. It could be a poster, a conference presentation, it could be anything, a scholarly work. But I'll tend to use the word paper because as a shortcut. The papers lead to concepts, and papers can have concepts associated with them. Papers also have people associated with them, and we're going to call the people associated with those papers experts. And if you have a lot of papers in a particular topic, maybe that's an area that you work in extensively. So papers are the connector between concepts and people. We'll see a lot more about that as we go forward. So we have concepts on papers. So PubMed in particular, as papers come into PubMed, they associate those papers with mesh terms, a nice controlled vocabulary of concepts, and then the other indexing services, whether they're Thomson Reuters or Scopus or others, also provide concept association with papers. And of course, people are on those papers as authors. So we're going to associate people to concepts on which they have published. So the body of data that we have at UF, we have 25,000 878 people at UF that have published at least one paper in our VIVO. So just go to VIVO, ask for all the UF people with at least one authorship. You'll get 25,800 distinct people. Okay? And those are faculty, graduate students, residents, postdocs, staff members, lab scientists, everything that are involved, that have been involved in the scholarship of the university since 2008. Our paper collection goes back to 2008. Those papers represent 18,520 concepts. So the concepts that have occurred in a UF paper since 2008, 18,000 of them. And that represents 20,408 papers. So we actually have more people than papers. That's interesting because it turns out that the average paper has about 7 authors. And in the last 2 years, UF crossed an interesting threshold where prior to 2 years ago, the majority of authors on UF papers were UF authors. As of about 2 years ago, the majority of authors on UF papers are now not UF authors. And so we crossed that 50% line about 2 years ago. So about 7 authors on a paper. About 3.8 of those authors are UF authors. So some papers have 1, some papers have 7 UF authors, but the average number of UF authors just went under half of the average number of authors on a paper. So collaboration is key, both within the university and across universities. So those are basic numbers. I'm going to take a little detour through some histograms because I think it's instructive to kind of see the data and to see the SPARQL queries that are producing the data and to see the JSON that results from those queries and then to see how that gets used in JavaScript before we try something a little more complex like an actual bimodal force-directed graph for expert finding. So the first thing I want to show is an AJAX histogram for organizational types. So we have about 12,000 organizations in our VIVO. They are funding organizations, colleges, universities that were attended, people that we've done business with, about 12,000 organizations. And they have types. Some of them are companies, some of them are museums, and they can have multiple types. So what we did was we created a little D3 program to draw a histogram, and then we created a query to get the most specific type for each organization in VIVO. And then we use that query in an AJAX call, and then we make that AJAX call in a web page. When you hit the web page, it makes the AJAX call, goes to VIVO, makes the query, drags back the data, and then displays it in a histogram. So that's what's going to happen. So let's see that happen, and then we'll take a look at the code. So if I click on this link, you'll see it's going to my GitHub site. All this material is available on the web. It's all in GitHub. You can have all of it. And you can also just click on these links and try these things yourself. So let's click on this AJAX histogram. So we click on it, and we go to the browser, and now we're going to count. And it's going to go like 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, we've long passed the threshold for which most people will wait for anything. And, you know, I could dress this up a little bit, and I could put some interesting stuff on the screen, and I could put a spinning wheel, and I could do all of that stuff. But in general, it's just too long to wait. So this idea that we're going to make a dynamic query into VIVO and pull back a significant amount of data and then display it, that's probably not what we're going to do. We're going to have to be a little smarter than that. So here's the histogram, and we can see what's going on. When we make this query, we find a lot of types, and so there's 12,975 organizations that are also things, that are also agents, that are also organizations. And you know, I know Dave's on the call, and you know, a couple of years ago in Miami, he showed some queries from UF that showed some data integrity problems in which not every organization was an agent, or not every agent was a thing. And we took that pretty close to heart and have tried pretty pretty hard to clean our data. So we have some pretty good top-level things. You see, the most popular reason that an organization's in our VIVO is that it's a funding organization. We see companies, we see publishers, we see universities, associations, the departments, which may or may not be academic departments of the university. And then we see this interesting class that we created in part of our ontology. There's 903 organizations that are actually part of UF. The rest of these are all outside of UF. So we have government agencies, foundations, et cetera, et cetera, et cetera. And if we get down to the bottom, we'll see there's still some things that are a little eyebrow raising. So we have an organization that's a building. We have 2 of them. And that has to be cleaned up. We see some organizations that are journals. And that's because, you know, somebody says they're the editor of the New England Journal of Medicine. Well, the New England Journal of Medicine and the VIVO ontology is an information collection, a collection of periodicals or whatever they call it. It's an information resource. It's not an employer. But we need to be able to say that somebody was the editor of the New England Journal. So now that New England Journal thing becomes an information collection and an organization. And so we see a few of those. Probably not the best way to handle it. And there's probably some way to clean that up. But when we see a histogram, we see our data pretty clearly. And so that is the data. Okay. So that's a little disappointing, the Ajax direct thing, because it just kind of took too long. So let's see what happens if we do the very same thing, but what we do is we actually do the query, and we save it as a JSON file, and then all we do on the web page is read the JSON file and make the histogram. Let's see what that looks like. Well, that looks pretty fast. So if the data has already been queried and already is a JSON file, reading that JSON file and making the histogram is plenty fast enough. Okay, so we can do that, and we can make some good results. And of course, that sets off a whole kind of thinking about how to get good results out of VIVO fast. So anyway, we can make a JSON histogram. Let's take a look at the code of this thing. So this turns out to be pretty simple. Down here, we're just looking for a parameter on the URL line so that we can pull a JSON data file and draw it. And all that does is goes up here and it says, oh, look at this. I can give a parameter and say I'm plotting orgtypes.json. Well, that's interesting. That probably means I can plot something else if there's some other JSON file in that directory, and the answer is yes. So I've got a little function that gets the parameter off the command line. I've got a little thing that gets the parameters off the command line and then calls a D3 JSON function for the data file and then draws that data. And this is the function that draws the data, and it draws it as a histogram. And I cut and pasted this right out of some books, so made it blue because I like blue. So I didn't do too much to it. So this basically finds the maximum value in the data. So for one graph, it's 12,973 or something is the maximum value. It's going to make a bar for every line, and that bar is going to have a width that's based on the actual value in the data divided by the max count to create a kind of percentage, and then it's going to multiply that by the width of the picture in pixels. That's it. That's the bar length. I'm going to put the text in there. I use a style sheet in order to make it look nice, and that's pretty much it. So this is a very, very simple D3 JavaScript example that reads a JSON file and plots it. And it turns out that this will plot any JSON file that has a certain structure. And the structure that this thing is looking for is it's looking for something called a count that has a value, something that has a label, and that has a value, and then all of those things are in some collection called results bindings. Well, anybody who's familiar with the Sparkle endpoint of VIVO knows that's exactly how VIVO returns its data. So if you make a query in VIVO and you say you want the output as JSON, you're going to get a data structure that has something in it called results, which has something in it called bindings, which has in it a set of rows, and those rows have things that you put in your Sparkle. So it's very easy to write a query, which then produces a JSON file, which then can be read and displayed using this function. And so up here, I'm just going to touch the parameter here, and I've already made a JSON file to just show us the UF org types. And if I do that, well, it was viewing the source. Sorry, I got to go over to here and actually, let's see. I want to view the source. I want that. Okay. And now I want to put in the UF in front of that. Okay, so that just read a different file. I just read a different file and displayed it. It happened so fast, and the general shape of the histogram is approximately the same, that you might have thought that nothing happened. But if you look closely, you'll see now we're showing 903 organizations, and they are all UF entities. And we see 232 departments and 205 centers and 133 academic departments. And this is the structure. This is the kinds of things that the University of Florida is made of from an organizational point of view. Okay? So that's our VIVO data for organizations. So let's go back and take a look at covered here. Okay. So we've seen a few JSON histograms for org types, and now we can see what did that data look like. Well, here's the concept. Sorry. We took a look at JSON histograms for organization types. Now I want to pull us back a little bit toward the expert finder. So for the expert finder, we need to have counts of concepts, and we want to know a little bit about those concepts so that we can start thinking about how they're going to get displayed. So let's take a look at the concept counts. And this is a pretty big JSON file because there's 18,000 concepts in there. So that was even reading a JSON file from disk. This is the 18,000 concepts displayed by the frequency of occurrence in papers. So all the concepts are here. All 18,000 are here. And now we're seeing that the most popular concept for a paper at the University of Florida is humans. That's not all that interesting. And then we see right behind it is animals. And then right behind that is female. So we apparently have a few more papers on female things than we have on male things. And then we have a bunch of papers that are about adults. And then we have a bunch of papers that are about middle-aged, and then aged, and then mice. And then adolescents. So mice and adolescents about the same. Treatment outcome, young adult, time factors, rats, United States. And then we start to get into actual scientific things like signal transduction or molecular sequence data, or here's a bunch of studies that were done on preschool children. Okay? So on and on and on. So for any of these, we now see that we know how many papers were done on the liver, or how many papers were done on flow cytometry, or how many papers on computer-assisted image processing. Okay? Since 2008. And of course, it would be very trivial in VIVO to issue an actual query and find those 148 papers. That's pretty simple to do. Okay, so we've seen the concepts. Now let's go take a look at and to get that query, to get those concept counts is a very, very simple query. So this is the very, very simple query. It says it's going to group by the, remember, to draw the histogram, you have to have something called label, and you have to have something called count. And here the label is a label on a concept. So the concept has a label. That concept appears as the subject area in something, and that something is an informational resource. And so this basically says the paper has a concept has a label, tally it all up, make that frequency table. So it's a very simple thing to get that frequency table, and you see the Sparkle query that's there. We'd also like to understand sort of concepts per paper. I spoke a little bit about authors per paper. Let's see about concepts per paper. So here's a histogram about concepts per paper. And so there's 156 papers that have one concept. 74 have two. And here's this distribution of concepts per paper up to one paper has 41 concepts. But take a look at this thing. So, if you have any data manager instincts at all, you would notice that bar. And when you notice that bar, you would want to know more about that bar. So I just found this a couple of days ago. I haven't investigated that bar yet, but I sure as heck have to understand why 3,000 papers have exactly 4 concepts. So is that an error in the way the concepts were attributed to papers, or did PubMed used to have a policy of attributing 4 concepts to a paper, or what happened that we have a chunk of papers, a very large chunk of papers that have exactly 4 concepts? That certainly seems out of the ordinary, and I would want to know more about that. So by seeing the data, we can raise interesting questions about the data. And this concepts per paper query is here. This is a nice one because, well, because it's a nested query. So first, for each paper, we find out how many concepts are on that paper, and then second, we count the number of papers that have that number of concepts. And so this kind of nested query thing shows up in Sparkle all the time. And so to make that frequency table, we need a nested query. Here's a nice example of a nested query. Okay, so now we know a little bit about the concepts and the papers and the authors. And so we're ready to kind of put this together a little bit. And this is how we're going to put them together. We're going to connect concepts to people via papers. So there's a concept, tumor suppressor protein P53. And that's one of the concepts that appears in that histogram. And there's a number of papers that the University of Florida has written about it. And there's a person who has written about tumor suppressor protein P53, Bill Strat May. Strat May happens to be the former director of our cancer center, and that makes perfect sense because he writes on tumor suppression, and there's tumor suppressor protein P53. So we can write a query that finds the authors that are associated with particular concepts. And in this case, we find Strat May. And it says here that Strat May has 2 papers on tumor suppressor protein P53. And so this connection between the concept and Strat May has 2 papers in it. So the tumor suppressor concept might have a few hundred papers. Strat May might have 100 papers. There are 2 papers that connect Strat May to tumor suppressor protein. Okay? And that idea is going to form the basis of how we're going to draw concept maps around concepts and people. Okay, so it looks like we're going to need a lot of data. So what we really want is all the concepts, all the people, and all the papers, and we want them all connected. And that's exactly what we have in VIVO. We have all of that. It's in VIVO. Now, it may be pretty big, and it may be hard to get out, and it may be that we have to organize it in a certain way for presentation, but the data is definitely there. Okay? And we've counted it already. So we know we have, 20,000 of, approximately 20,000 of each one of those things. But I'm going to say that we need some kind of pre-counted JSON data to be ready for web requests. And I'm going to call that a concordance. So we're going to go through all of the VIVO data and count it. And I'm going to say, okay, for each of these 18,000 concepts, which concepts occur with those concepts, and which authors occur with those concepts, and how many times do they occur, and which papers are in those occurrences. And so we'll be able to build an optimized data structure that associates concepts with other concepts and with authors. And so we use a Python program to process a Sparkle query. And so here's the Sparkle query, and this is pretty simple. It says create a set of concept, author, and publication. And I want publications, their names, concepts, their names, authors, and their names. And I just want those 6 things every time they occur together. Concept, author, paper. Every time there's a unique combination of those things, show it to me. Okay? So this is like a multi-way join, if you're familiar with SQL, and it's just finding academic articles and their names and making sure they have a particular concept and that there's a particular author and that the author has a name and all of that. And then it's going to show them in an order, and then it turns out that there are hundreds and hundreds of thousands of these. And we're just not able to do it that way. And so we thought we would just be able to make a Sparkle query and make a concordance, but it actually was too big. And so to actually even make that Sparkle query was going to run longer than I had time to wait. And so we needed a different way. And so the different way was to use a Python program for each concept define concurrent concepts and authors. And so we did that. And let me go out to my desktop and show you that. So we have a little Python program, and we can, sorry, right here, a little Python program. And this basically looks up every single concept. So it looks up every single concept in VIVO, all 18,000, and it issues Sparkle queries, and it finds the concordant concepts, and it finds the concordant authors. And you can say, well, Mike, you got to make, you got to make like, 50, 60,000 Sparkle queries to do that. Oh yeah, and that's already been done. So we do all of that, we make all the queries, and we make a big concordance. And in Python, it's very easy to then keep that concordance on disk. I use something called a Python shelf. So there's delivered functionality in Python called a shelf. It's basically a disk-based dictionary, and I can make a very comprehensive concordance on the disk that has pre-digested all the concepts, their counts to other concepts, and their authors and their names and all of that. So when I do that, I get a concordance file that's out here. And when we look at the properties on that, it's 177 meg. So all right, 177 meg. But it turns out that's a little big to read into a web page. So, we were choking earlier in this demo around trying to read, I don't know, 6 meg. So we're not going to be able to read 180 meg. So it was too big. So what we did was we used Python to subset the concordance and select some dense connections. And so we subset the concordance. There's a little subset software in there that has tunable parameters on how you want to subset the concordance, and we make the subset. And the subset is 50 meg. That's also pretty big. So the subset said, well, for two concepts to be connected, you got to have at least two things in the link. For a person to be connected to something, you got to have at least two papers. And even with that, you only get about a third reduction in the total size of the concordance. I could probably make the concordance a lot smaller by getting rid of those non-interesting concepts like human and animal. And nobody's going to ask me who's the expert at UF on animals, and it's non-specific. And so we probably could trim it from the top and reduce by tens of thousands the connections and authors and papers associated with those concepts, and that would probably be a better way to trim it out. But regardless, we have a subset concordance and we're ready to use it. Okay, so now we're ready, and we're going to take this concordance and we're going to select some dense things, and now we're ready. And so the first thing I did was I made a bimodal force-directed graph, and I used some fictional data that we had, and I just relabeled it. So this is not a real example, okay? But what I want to do is I want to show this. I want a bimodal force-directed graph of concepts and people, where I select a concept like P53 suppressor protein, and I find all the concepts that are associated with that, and I find all the people that are associated with either the concept of interest or concepts related to the concept of interest. And I do all of that based on the number of papers that associate those. So I want to make a graph like this, but I want to use the data that we've just been talking about. So now we're going to get to the real thing. So I talked about the concordance subset process, and it's trimmed the concordance globally to only concepts that appear in 2 or more times. Co-occurrence of concepts has to be at least 2. Authors have to publish at least 2 papers. And then for a specific concept, I find all the co-occurring concepts, and for each of those, find all the people who published on that concept. And I produce a JSON file ready for display. And I have a little Python program that can read the concordance, the subset concordance, and write the JSON that's good for display. And obviously that's not going to scale the way we want it to, so we'll come back to that idea. But for now, if you give me a concept, I can make a little JSON file and I can show it to you using a force-directed graph. So I've done that, and the concept that we're going to display is Veterans Administration Care, because we have a VA hospital across the street at UF. And then if we go to the subset, make the JSON for that concept, and demo it, we get this. And that actually is the VIVO data from UF, a force-directed graph showing people and concepts. And this is all just related to Veterans Administration. So right in the middle here, United States Department of Veteran Affairs, right there. And I can like drag this whole thing around based on that. But right in the middle, and we'll improve the visualization. Right in the middle is the United States Department of Veteran Affairs as a concept. And then all these other dots are things that we have done in relationship to the United States Department of Veteran Affairs, like intracranial aneurysm or insurance coverage. And then for every one of those things, we show people, like Bill Miles here, who's connected to concepts which are either connected to the VA or connected to concepts that are connected to the VA, that co-occur with the VA. And so we're able to say, okay, Bill Miles, he's got 4 papers and 4 papers that connect him to these concepts, which are in turn connected to the VA. And so he's done a little work in the VA. Great. And his paper doesn't have to be directly connected to the VA. It has to be connected to the concepts that co-occur with the VA. So anyway, we have the data and we have the picture. And this clearly, this is a work in progress. So this is how far we've gotten. But we actually are able to pull real data out of VIVO and really display it using a force-directed graph for the purpose of expert finding. And now what we have to do is some of these things. So I'm going to make the size of the concept nodes be related to the number of papers. So we'll know there's a lot of work in a particular area, not a lot of work in some other area. I'm going to size the author nodes in 2 rings. I'm going to have an inner ring based on the number of papers that they have on that concept, and an outer ring based on the number of papers they have total. So we can see this is a highly published author, and he doesn't publish much in the VA. Or this is a highly published author who has a lot of papers in the VA, or neither, whatever combination it is. And you'll be able to see that very quickly with that kind of display. We're going to weight the connections based on the number of papers in the connections. So we already have all this data. It's just a matter of making it show up in the visualization properly. We're going to provide hover navigation for the concepts to the concept in VIVO, and hover navigation for the people to their profile in VIVO. So you see Bill Miles, you're able to click on Bill Miles and go straight to VIVO. We're also going to link the display of papers comprising the connection. So as you hover over a connection, it says it has 4 papers. You'll see the 4 papers, and you'll be able to click on them and go into and find the papers. We're going to provide user controls for trimming and positioning the network. You saw the network, even for a concept, relatively simple concept like the VA, has a lot of second-order connections. And so a user is going to want to be able to have a slider that says, really, show me I only need to see things that are above 2 or above 10 or whatever it is until I get a network that's about the size I can comprehend, and then add some other things based on their interest. And we'll provide some navigation tools that show the concepts that are in that network, and they'll be able to select them out so that they can say, yeah, I'm not interested in animals or humans or any of that. I'm really interested in insurance coverage and things that are related to things like insurance coverage. So you'll be able to check and uncheck concepts and see the network with just the things that you select. Then we're going to have to provide a means for accessing all the concordance data without having to generate a new JSON file via Python, unless we do that in real time. And it does take a couple of tenths of a second to produce the slice, the JSON slice of the concordance via Python. But right now I don't have a Python pathway from JavaScript. So Chris and I are talking about what kind of infrastructure we might put in place to be able to get the simple architecture, Tablet talks to VIVO, to be responsive for a problem that requires this level of computation to take the large data and take it down to some reasonable size set of data for presentation. We're going to provide recentering, so you'll be able to double-click on either a concept or an author and redraw the entire network around the selected concept or author. So you might have started with the VA, but when you see back pain, you might say, oh yeah, no, I want to know all the things. I want to know everything that UF knows about back pain. Double-click on back pain and see a whole brand new graph on back pain, which will then be collected back to the VA, and maybe we'll provide breadcrumbs so you can go back and forth. But you should be able to redraw the network around anything that you've selected, whether it's a concept or an author. And And then once you've found some authors and kind of collected them as you go, and provide a means for outputting the list that you've generated of authors of interest, people of interest, who are the experts that you've identified through your navigation of the concept map, and walk away with 5 URIs and the names of the people that go with them, and end up knowing that you're really interested in StratMay and a few other people from the university because you found them using the expert finder. So, as I said, all of this I develop in the open, so every mistake I make is perfectly available to all of you, and so you'll see things in these things where you'll see code being developed. Everything is available there, and I developed this particular thing as part of the Some Vivo Things website, so that I can post JavaScript into the website and then have me and you click on these things and take a look as we go along. So that's as far as we've gotten, and with that, maybe we can take questions about why I'm doing what I'm doing, why I'm doing it this way, what I might do next, how things work, whatever you want to talk about.
Well, thank you, Mike. That was a fantastic presentation. I really appreciate all the work you put into that. That was pretty awesome. Are you going to be able to share that presentation with us, the slides?
Oh, certainly.
Yeah, if you send them to them, I'll make sure they get published to everybody. Or if you put them up on Figshare, we can share them that way.
Sure. They're probably in VIVO.
So, Mike, this is John at Cornell. I think I lost you a little bit where you were sort of going on. So you mentioned showing the VA, and then if you decided you were interested in back pain and wanted to regenerate a new version of the graph that was focused on back pain, how much the concordance that you create, does that allow you to kind of pre-compute for every concept, so that you then would have
yes, yeah. So the concordance has all of the possible combinations of authors and concepts have already been computed, tabulated, and are available in the concordance. What has to happen when you click on something? So if I can't, we can imagine coming in here and saying, well, here's insurance coverage, okay? And I want to double click on insurance coverage, and then something good is supposed to happen, right? and the actual architectural pathway is that when I double click on insurance coverage, the indication that I'm interested in insurance coverage has to go to that slicer, to the make graph JSON Python program currently, or a reasonable facsimile of that thing. But what that thing is doing is it's going into the concordance, and it would find everything that VIVO knows about insurance coverage for the purpose of drawing an insurance coverage bimodal force-directed graph exactly the way you're seeing it, but for insurance coverage. And so it would go in there, find everything about insurance coverage, and come back with the JSON necessary to draw this graph, which then the graph would just be updated based on the contents of the JSON file. And so D3 actually could do that. If you swap out the JSON file, it'll just redraw. And so all I have to do is make a new JSON file and put it where this thing is expecting to find its JSON file, and it will redraw this graph with insurance coverage at the center and everybody associated with that. And so the detail there is that has to happen in real time. Right now, right now, if you say, well, I want to see insurance coverage, I say, great. I go over to the command line, make a slicer on insurance coverage, and make a JSON file, pop it in here, and we'd see the insurance coverage graph. And that would take me 5 minutes to do by hand, and that's totally unacceptable. I'm not available to do that by hand. So it has to work the way I described, where it can just happen from a prompt.
Well, right now,
the actual Python computation takes about 0.2 of a second. So it's not. It only takes me 5 minutes because I got to fumble around with various things on my interface. But the actual computation is fast.
And you're doing this to create a JSON file that's.
You get to.
Go ahead. Sorry.
I was just going to say, you think you can get to more or less real-time performance once you wire up the
slicer.
Yeah.
Yes, I actually do. That's why we've sort of gone in this direction. Is that this make graph this right here, make graph JSON. This little thing reads the concordance and writes the file expected by D3. And the only input to it is a single concordance URI. So you give it a concordance URI, and it goes and it makes and you can see that here. Here's 3 concept URIs that I was using for testing. So pulmonary hypertension, the VA, attention deficit disorder. You select one of those, and bang, you end up with a slice, and it slices it out and makes a JSON that D3 expects. And so when you come in here and take a look at this, you'll see that this is similar to the histogram. It's reading a D3 file. Sorry. I gotta get this off the screen. I gotta get that off the screen so that I can scroll down. Right. Okay. So in here, it's just reading graph.json. Whatever file is called graph.json, that's what it's going to read, and then it's going to draw the force-directed graph. And so when we come back out here and look for graph.json in here, there it is. And this is the actual file that it's displaying. And you see it, it's a graph, okay? Source and targets, and those source and targets have to be numbered consecutively, and that's what the little Python program is doing. It's taking the concordance, which is all conceptual and full of VIVO URIs and all of that, and it's turning it into a hyper efficient data structure for D3 to display. Okay. And so here's all the things that are in there. You see, home care services. There's its concept URI in VIVO. There were 2 papers that are published on it. It is a concept. It is concept number 136 in this particular file, for the purpose of targets and sources down here. Okay, so they get renumbered on the fly for the purpose of drawing a very efficient graph, and that's what that little slicer does. It finds all the things that are associated with the United States Department of Veteran Affairs, like outcome assessment, arthroplasty, and analgesics, and we know that this is connected to that, and if we went down into the target source thing, we would find how many times it's connected. And then so we've written 15 papers on that have VA as a concept. Okay, so that would give me the data I need to make the bubbles different sizes. So that's so that's already in there. Okay, and same thing for the authors. I have to add one more parameter to the authors. Right now, when you're looking at an author, so where's an author? There, Lindsay Atchison Thompson, right? She wrote 2 papers on this concept. Okay, sorry, that's her URI. She wrote 2 papers that are connected to a concept. You'd have to look in the target source to see what it's connected to. So this just says there's a person named Lindsay Thompson. She's a person. She's written 2 papers. That's her URI in VIVO, so that we can navigate into VIVO if we need to. And in this particular little slicer file, she's node 160, and then node 160 is connected to a few concepts. So that's a very, very efficient data structure for drawing the force-directed graph.
And would you imagine regenerating the concordance on kind of a nightly basis, or after every publication ingest, or
yeah, after every publication ingest, right? So we put in pubs once a week, and that would be the right time to redo the concordance, right? And redoing the concordance takes several hours the way I'm currently doing it, but it's manageable. It's not. It doesn't take more than a week. So,
yeah.
All right.
So, Mike, this is Dave.
Hi, Mike. This is Don Ellsborg over at CU.
Yeah.
Thanks for this demo. It looks great. And my question for you is, this looks pretty similar to the Find an Expert graph that Simon Porter did from Melbourne.
It's very similar.
I know he's going off of Funnelback, though, so going against the index as opposed to going against Sparkle. And, how does yours, have you looked at his application and kind of compared it?
I was in Melbourne in January, and Simon and I talked quite a bit about this. And the reason that I went in this direction is that I think it's transferable. So we're not going to have funnel back, um, but I wish I did. That thing is fast and smart, and he's got some really good queries that can return the bimodal concept connections pretty quickly, whereas I have to kind of digest it and slice it. But if we can master the slicing, this thing will be very fast. So I'm not too worried about getting to kind of a generic solution that other people would be able to implement without licensed products.
That's perfect because that's what we're concerned about to implement as graph. We'd have to get funnel back. I know with 1.7 though that it's my belief that search is going to be decoupled, or there's going to be a capability to decouple Solr indexes and put in perhaps different kind of indexes.
That may well be. Maybe John can speak to that.
And,
Yeah,
and I guess
that's certainly the intention. I'll be interested in working with anyone who wants to actually make that happen. But yes, the search has been put behind an interface, and so it should be pretty well decoupled.
Dave?
Yeah, I was going to suggest one thing you might be able to do to finesse your JSON generation issue is to create yourself a secondary namespace in the triple store, and then materialize your triples, your second order and third order triples, into that triple store, and then your Sparkle interface could interrogate those second order triples.
Ah, very nice. Yeah,
So
I see how that would work. That would result in some pretty fast, potentially very fast, Sparkle queries using the same technology we've been using all along. Right.
Right. Yeah.
Yeah, that's
effectively
pretty nice.
materialized view.
Yeah. That's pretty clever. Yeah, I like that idea.
I guess the second question.
I just want to say thanks for sharing this, Mike.
Go ahead, Patrick.
Sorry, I got a delay. I'll call in. So.
Yeah, we had another question.
Go ahead, Patrick.
So, Mike, are your concepts equivalent to mesh terms? It looked
almost always, because the vast majority of our SCOS concepts in our VIVO are coming from PubMed.
Okay. I can give you a mapping of PMIDs to UMLS concept codes if you're interested.
So to UMLS concept codes, that's very interesting. Yeah, I would like that. Yeah.
That'd be very helpful.
Yeah, right now the only mass-produced association that we have for papers to concepts is PubMed. So we don't use Thomson Reuters keywords because they're proprietary, so we don't use them. So if we know the material is produced by the author or by some open source source, if we can verify that the keyword source is open and reusable, then we use it. Otherwise, we can't. So we're not using Thomson Reuters keywords, for example.
Patrick, you had a question. I think we got time for one more question.
I did actually. I just wanted to say that it's awesome that you put this out on GitHub. While we're sitting here, I pulled out the concepts that we're attaching to people, and pulled up your histograms. So now I'm going to share this with people here. And we also have like humans at the top, and then adults, and then females and males. We're also more female than male here at Duke. So.
And where is this?
This is at Duke.
Oh, very good.
Gee, so there's the benefit of sharing. During the call, he was able to run his own at Duke.
Yeah, it was great. It was super easy. I just had to point it at the right JSON file.
Very nice.
Thanks.
Okay.
Well, thank you, everybody. I'm sorry to cut it short here, but we're running up against the 2 o'clock, and I promised I would keep this to an hour. So thanks again, Mike. That was a fantastic demonstration. You guys there'll be the call notes will be published. I should have the video up in a week or so, and I'll get the link out to everyone with the link to the presentation slides that Mike has. But always, Mike is mconlon17 on GitHub. Again, that's mconlon17 on GitHub. And so, again, thank you, everybody. Thanks for coming, and we'll see you in our call in 2 weeks.
All right. Thank you.
Thanks, Mike. Thanks, Chris.
All right.